Our objectives in this lesson are the following. Define logical operators. Distinguish logical operator used in a proposition. Perform different types of operations on propositions. And translate English sentences into logical expressions and vice versa. In our previous lesson, I have already introduced the different logical operators and their meaning. Now, I have included their corresponding symbols as well as other alternative words that you might encounter that have the same meaning. The first one is negation, denoted by this symbol. This is tilde, and this is read as not P. Alternative words for not are it is not the case that or it is not true that. Next one is conjunction, and it is denoted by this symbol. This is read as P and Q. Some of the alternative words for and are although, however, while, nevertheless, moreover, yet, furthermore, but, also, still. Next one is disjunction, denoted by this symbol. This is a wedge or vel. This is read as P or Q. Alternative word for or is unless. The fourth one is implication. We have here a single-sided arrow going to the right. And this is read as if P, then Q. Alternative words for if then are P implies Q. Now we also have Q provided P, Q whenever P, Q if P, Q follows from P. But take note that if these words are used, then Q is written first before P. The last one is biconditional. We have here a two-sided arrow, and this is read as P if and only if Q. Alternatives for if and only if is its abbreviation IFF, or we have P is equivalent to Q. If we have MDAS, PEMDAS, or GEMDAS, we also have order of precedence in logical operators. This means negation has higher precedence than conjunction, conjunction has higher precedence than disjunction, disjunction has higher precedence than implication, and implication has higher precedence than biconditional. Let me give you an example. If I give you this with the corresponding propositions and I ask you to translate this in a sentence, how would you know if this is equivalent to this one or this one? This is where order of precedence comes in. Since conjunction is of higher precedence than disjunction, then the correct answer here is this one. Because operands associate with the operator of higher precedence. Let me give you an example for you to understand this better. Let us say I give you 0 plus 1. 0 and 1 are the operands, and the operator is the plus. So here, P and Q are the operands, and the operator is the conjunction and disjunction. Since operands associate with the operator of higher precedence, therefore our operands P and Q associates with conjunction, not with disjunction, because conjunction is of higher precedence than disjunction. Let's have another one. Is this equal to this or this one? Again, we have here disjunction and conjunction. And conjunction is of higher precedence than disjunction. Therefore, the correct answer in here is this one. The operands Q and R associate with the operator of higher precedence, and conjunction is of higher precedence than disjunction. How about this? This is equivalent to this. Since implication is of higher precedence than biconditional, then our operands P and Q associate with implication. Last one. This one is equal to this one. Again, we have here biconditional and implication. Implication is of higher precedence than biconditional. So our operands Q and R associate with implication. Some more rules. If there are two conjunctions or two disjunctions, the operands associate to the left. Let's have an example. So if this is the case that we have here two conjunctions, then the operands associate to the left. Let's have another one. We have here two disjunctions. Again, operands associate to the left. If we have two implications or two biconditionals, the operands associate to the right. Let's have an example. So we have here two implications. The operands associate to the right. So Q and R here should be grouped. Another one, two biconditionals. Again, operands associate to the right. Let us discuss now the first logical operator, the negation. The negation of a proposition P is denoted by this symbol. Again, this is tilde, which is read as not P and is defined through its truth table. Here is the truth table. So we have here the proposition P and not P. If the truth value of the proposition is true, then the negation of that is of course false. If the truth value of the proposition is false, then the negation of that is true. Let's have some examples. State the negation of the following. P is the proposition the teacher requires the students to buy notebook. So we are going to negate this sentence here. We could say, it is not true that the teacher requires the students to buy notebook. We can also say, it is not the case that the teacher requires the students to buy notebook. Number 2. Q is the proposition 1 is a prime number. To negate this, we could say 1 is not a prime number. Number 3, R is the proposition everyone in grade 11 is 17 years old. To negate this, we could say it is not the case that everyone in grade 11 is 17 years old. Or we could also say it is not true that everyone in grade 11 is 17 years old. Bear in mind that sometimes negation is not necessarily the complete opposite. Take for example this one. The negation of R states that there are grade 11 that are not 17 years old. If you are going to get the complete opposite of this statement, then it would be everyone in grade 11 is not 17 years old, which is incorrect. Because what we want to say here is that not everyone in grade 11 is 17 years old. The next one is conjunction. The conjunction of propositions P and Q is denoted by this symbol, and this is read as P and Q, and is defined through its truth table. Here is the truth table. So we have here propositions P, Q, and then P and Q. So if the truth value of the proposition P is true, and the truth value of the proposition Q is also true, then P and Q is true. If the truth value of the proposition P is true, but the truth value of the proposition Q is F, then P and Q is F, false. If the truth value of the proposition P is false, and the truth value of the proposition Q is true, P and Q is still false. And last one, if the truth value of the propositions P and Q are both false, then P and Q is false. P and Q here are what we call conjuncts. To summarize this, the conjunction P and Q is true only when both P and Q are true. Take a look at here. The conjunction P and Q is true only if both P and Q are true. If one of the propositions is false, then P and Q is false. Let's have an example. Express the conjunctions below in sentences or symbols. P is the proposition, procrastination is the thief of time. Q is the proposition, those people who procrastinate cram. Number one, we have here P and Q. So our P is procrastination is the thief of time. And this symbol is and. This one, our proposition Q, those people who procrastinate cram. So we have procrastination is the thief of time and those people who procrastinate cram. Number two, so we have here negation of P and Q. So we are going to negate our proposition P. So this will be procrastination is not the thief of time. So we have here not. And then the proposition Q, those people who procrastinate cram. So we have here procrastination is not the thief of time and those people who procrastinate cram. This time we're going to translate this into logical expression. Procrastination is the thief of time. That is our proposition P. And, so we have here the symbol for and. Those people who procrastinate do not cram. So what we did here is we negate our proposition Q. So this will be not Q. So we have P and not Q. Last one, procrastination is not the thief of time. So in here, we negate our proposition P. So negate proposition P, and then we have and. Those people who procrastinate do not cram. So we also negate our proposition Q. So this will be not Q. So we have not P and not Q. The third logical operator is disjunction. The disjunction of propositions P and Q is denoted by this symbol. This is called vel or wedge, which is read as P or Q and is defined through its truth table. So here is the truth table for disjunction. So we have here the propositions P and Q and P or Q. If the truth value of proposition P is true and the truth value of proposition Q is also true, then P or Q is true. If the truth value of the proposition P is true and the truth value of the proposition Q is false, then P or Q is still true. If the truth value of the proposition P is false and the truth value of the proposition Q is true, P or Q is still true. But if the truth value of the propositions P and Q are false, then P or Q is also false. This time, P and Q are called disjuncts. By the way, we have two kinds of OR. We have the inclusive OR, which means P or Q or both, or exclusive OR, either P or Q but not both. Let me give you an example. Let's have first the inclusive OR. This is our symbol. So let's have I am singing and I am washing dishes. Now, can I both do this at the same time? Can I sing while I'm washing dishes? Or can I wash dishes while I'm singing? Yes, I could. So this is an example of inclusive OR. So this is A or B. Now, for the exclusive OR, here is our symbol. It is a circle that has a plus inside. Here are our propositions. I am brushing my teeth. I am eating. Question. Can I do both of this at the same time? Can I brush my teeth while I'm eating? Or can I eat while I'm brushing my teeth? No, I can't. This is an example of exclusive OR. So this is C, exclusive OR D. So again, if it is inclusive OR, you can do either of the two or you can do both. If it is exclusive OR, you can do either one but not both. Now, what do we use in logic? In logic, we use the inclusive OR. P or Q or both. Look at here. If this is true and this is false, P or Q is still true. If this is false and this is true, P or Q is still true. If both are true, is still true. So P or Q or both. To summarize, the disjunction P or Q is false only when both P and Q are false. So it's here. It is only false if both P and Q are false. If at least one proposition is true, then P or Q is true. If we say at least one, it could be more than one. So it could be both. Still, P or Q is true. Let us have some examples. Express the disjunctions below in sentences or symbols. We have here three propositions. P is the proposition, 5 is an odd number. Q is the proposition, 6 is an even number. And R is the proposition, 7 is an even number. Number 1, we have Q or R. Our Q again is 6 is an even number. Then we have OR, and then our R is 7 is an even number. So we have 6 is an even number or 7 is an even number. Number 2, we have not P and Q. So we are going to negate our proposition P. How are we going to negate this? We can say 5 is not an odd number. Or we can also say 5 is an even number because the negation of odd is even. And then we have here and. Then our Q, 6 is an even number. So we have 5 is an even number and 6 is an even number. Number 3, let's going to transform this into logical expression. Either 5 is an odd number or 6 is an even number or 7 is an even number. Notice this comma here. This means this is considered one statement. So we are going to group 5 is an odd number or 6 is an even number. So again, 5 is an odd number is our proposition P. And then we have OR. And then 6 is an even number is proposition Q. This is one group. Here is the comma. And then we have here another OR. And then 7 is an even number, which is our R. Next one, either 5 is an odd number, or 6 is an even number, or 7 is an even number. So the comma is here, so this is one statement. 5 is an odd number, this is our proposition P. And then we have OR. 6 is an even number, that is proposition Q. Or 7 is an even number and that is our proposition R. This is one group because everything after the comma here is considered one statement. Last one, either 5 is an odd number and 6 is an even number, or 5 is an odd number and 7 is an even number. So here is the comma. So this statement is considered one group and after that is also considered one group. So 5 is an odd number, that is proposition P. And then we have and. 6 is an even number, is proposition Q. And then we have here or. Then 5 is an odd number, again is proposition P. And then we have here and. 7 is an even number, is proposition R. When translating from English sentences to logical expressions, the comma would be useful. So take note on how to use them properly. The next one is the implication or conditional. The conditional of propositions P and Q is denoted by this symbol. And this is read as if P, then Q, or P implies Q, and is defined through its truth table. Here is the truth table. So again, we have here propositions P, Q, and then we have P implies Q. If the truth value of the proposition P and Q are both true, then P implies Q is also true. If the truth value of proposition P is true and the truth value of proposition Q is false, then P implies Q is false. If the truth value of the proposition P is false and the truth value of the proposition Q is true, P implies Q is still true. And if P and Q are both false, P implies Q is still true. The proposition P here is what we call the hypothesis or antecedent. This is the if part, while the proposition Q is called the conclusion or consequent. This is the then part. To summarize the truth value, the conditional P implies Q is false only when true hypothesis leads to a false conclusion. So, if you have true hypothesis followed by false conclusion, that is the time that P implies Q becomes false. In logic, the hypothesis need not cause the conclusion, meaning they don't have to be actually related. Let's have examples. Express the conditionals below in sentences or symbols. Again, we have here three propositions. P is the proposition COVID-19 is a virus. Q is the proposition COVID-19 is deadly. And R is the proposition COVID-19 is airborne. Number 1, we have P implies Q. So our P is COVID-19 is a virus. Since we have here implies, then we have if then. Don't forget the comma after the if statement. And then we have Q, and that is COVID-19 is deadly. So if COVID-19 is a virus, then COVID-19 is deadly. Number 2, we have not P implies not Q and not R. So first, we are going to negate our P. Our P, COVID-19, is a virus. Negating that will become COVID-19 is not a virus. Notice this not here. This is just to emphasize that we negate our proposition P. And then we have here implies. So we have if then. If COVID-19 is not a virus, comma, then. Now we have not Q. Our Q, COVID-19 is deadly. So we are going to negate this. This will become COVID-19 is not deadly. And then we have here and. This is not R. So we are going to negate our proposition R. We could say COVID-19 is not airborne, or we could also say it is not true that COVID-19 is airborne. So if COVID-19 is not a virus, then COVID-19 is not deadly, and it is not true that COVID-19 is airborne. Number 3, if COVID-19 is airborne, then it is a virus and it is deadly. Notice this comma here. So this is one statement. COVID-19 is airborne. That is our proposition R. And then we have if then. So we have implies. It is a virus. This is our proposition P. Then the symbol for and. Then it is deadly. That is our proposition Q. So this is in one group again because everything after the comma is considered one statement. Last one, if COVID-19 is not a virus, then it is not true that either COVID-19 is deadly or it is airborne. So let's have this one first. COVID-19 is not a virus. This is a negation of our proposition P. So this is not P. And then we have if then, so we have implies. And then we have here COVID-19 is deadly. That is our Q. Then we have or. It is airborne. That is our R. But it says here, it is not true. So we are going to negate this statement. So we're going to put the negation here. So again, we're going to group this because everything after the comma is considered one statement. The last one is biconditional. The biconditional of propositions P and Q is denoted by this symbol or PIFFQ, which is read as P if and only if Q, and is defined through its truth table. Here is the truth table for biconditional. So again, our propositions are P and Q, and then we have here P if and only if Q. If the truth value of P and Q are both true, then P if and only if Q is also true. If the truth value of proposition P is true and the truth value of the proposition Q is false, their biconditional is false. If the truth value of P is false and the truth value of Q is true, their biconditional is still false. But if the truth value of both P and Q are false, then their biconditional is true. This time, P and Q are what we call components of the biconditional. To summarize the truth value, the biconditional P if and only if Q is true if the truth value of both components are the same. So meaning the biconditional P if and only if Q is true if the components are both true or both false. Let's have an example. Express the biconditionals below in sentences or symbols. Again, I have here three propositions. P is the proposition, I love math. Q is the proposition, I love teaching. R is the proposition, I am a math teacher. Number one, I have here R if and only if P. So our R is I am a math teacher if and only if P. I love math. Number two, I have here the group of P and Q implies R. So this one is considered one group. So our P is I love math. This one is and our Q is I love teaching. Since I have here implies, then I should have if then. And then we have here R, I am a math teacher. Number three, I love math or I love teaching if and only if I am a math teacher. Here is our connector, if and only if. So this one is considered one statement. I love math is P and then or I love teaching is Q. This is one group because here is our connector. Then if and only if I am a math teacher, that is R. Last one, if I don't love math, then I am not a math teacher. If I don't love math is the negation of our proposition P. So this is not P. Since I have here if then I should have implies. I am not a math teacher is the negation of our proposition R. So this will be not R. Let's have an activity. Translate me in English sentence. So this time I have four propositions. It is windy. Vincent is flying a kite. Sydney played all night. Chris is patient. Number one, we have not R. So this is just the negation of proposition R. So we could say Sydney did not play all night. Or we could also say it is not the case that Sydney played all night, or it is not true that Sydney played all night. Number two, P and Q. My P is it is windy, and then I have here and Q is Vincent is flying a kite. Number 3, I have here S or not S. S is Chris is patient. Or I am going to negate S, so I could say Chris is not patient or Chris is impatient. Number 4, I have here the group of Q and R implies S. Q is Vincent is flying a kite. This one is and. Then R is Sydney played all night. Since I have here implies, then I should have if then. And then S, Chris is patient. Last one, I have here Q, if and only if P. So Q is Vincent is flying a kite. If and only if P is it is windy. For the summary, here are the things that we discussed in this lesson. Take time to read this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. This time we're going to translate the following sentences into logical expressions. Number 1. Ma'am Sumera is my favorite teacher, even though she is not teaching anymore. So the first thing to do is to identify the propositions that we have here. So one is, Ma'am Sumera is my favorite teacher. I could use letter S for Somera here, proposition S. And then another proposition here is, she is not teaching anymore. I could use T here for teaching, but notice that I have here not. So I am going to negate my T here. So not T. And then what else do we have here? Our connector is even though, which is an alternative for and. And the symbol for and again is this one. So now let us write this. So we have S and not T. Number 2, Jajang is neither a singer nor a dancer, but rather a painter. So again, first thing to do is to identify the propositions. We have here one, Jajang is a singer. Let me use S for that. And then Jajang is a dancer. Let me use D for that. And then Jajang is a painter. Let me use P for that. Now, notice that we have here neither nor. So, meaning neither nor is the negation of either or. So, let me construct first the or. So, I have here Jajang is a singer or Jajang is a dancer. But since neither nor is the opposite of or, then I am going to negate this. And then what else do we have here? But. And this is an alternative also for and. And our symbol is this one. So we have and. Jajang is a painter and that is P. Now, there is another way of doing this. Since neither nor means Jajang is not a singer and Jajang is not a dancer. So I could say not S and not D. So again, because neither means opposite, so this is not a singer, not a dancer. But this time we're going to use and because both of this is not Jajang. And then we have but, and then we have Jajang is a painter, so we have P. Gets? Our next lesson is truth values of propositions.